Hello and welcome to Data Engineering with Subhadeep. In this video, we are going to explore how to use Python's asynchronous capabilities to dramatically speed up your data engineering workloads. Many data engineering tasks are I/O bound. This means the program spends most of its time waiting for data from a network, a database, or a disk. During this waiting period, your powerful CPU is doing absolutely nothing. This is a huge source of inefficiency in our data pipelines. Here is a visual comparison. In a synchronous model, tasks execute one after another. If a task is waiting, the entire program waits. In an asynchronous model, when one task starts waiting, the program can switch to another task. It doesn't wait idly. It starts other tasks and manages them all concurrently. This leads to a much shorter total execution time. Python's built-in library for this is called Asyncio. It works with a few key concepts. The keywords async and await are used to define special functions, called coroutines, which can be paused. The event loop is the coordinator that runs these coroutines, switching between them intelligently whenever one of them is waiting for I/O. Let's consider a practical data engineering scenario. Imagine we need to build a dataset by fetching information from multiple REST API endpoints. Each API call involves a network request, which means waiting. Our goal is to fetch data for 10 different products concurrently. First, let's look at the traditional synchronous approach. We use the popular requests library. We define a function to fetch data for a single product. Then, in our main block, we loop through the product IDs and call this function one by one. The key thing to note is that the program completely stops and waits at the requests.get line for each and every call. Now, for the asynchronous version, we use the AIO-HTTP library, which is designed to work with async.io. Notice the async and await keywords. We define an async function to fetch the data. In our main async function, we don't call the fetch function directly in a loop. Instead, we create a list of tasks, one for each API call, and then use asyncio.gather to tell the event loop to run all of them concurrently. So what's the result of our comparison? The difference is staggering. The synchronous code, which makes 10 calls one by one, takes over 10 seconds. The asynchronous code, which runs all 10 calls concurrently, finishes in just over 1 second. It's roughly the time it takes for the single slowest API call to complete, not the sum of all of them. This is a massive performance gain. So, where can you apply this in your data engineering work? Async is perfect for any task involving multiple independent I/O operations. Think about extracting data from many APIs, running a large number of simple database queries, uploading or downloading thousands of small files to cloud storage, or handling real-time data streams. If your code is waiting, you can likely benefit from async. It is worth mentioning that Asyncio is not the only option. Python's concurrent.futures module provides a simpler way to achieve concurrency for I/O-bound tasks using threads. With Thread Pool Executor, you can run existing synchronous functions, like our original request-based one, in parallel. This can be easier to integrate into a large, existing codebase without rewriting everything to be async. That's all for this tutorial on Python's async capabilities for data engineering. By embracing concurrency, you can build significantly faster and more efficient data pipelines. If you found this video helpful, please like, share, and subscribe to the channel for more content. Thank you for watching.